Hello, my name is Laquela Roberts, and I will be talking about Module 2, Lesson Chapter 9, Geometric Figures. Let's get started. Okay, so we're going to demonstrate the relationship between the measures of angle 1 through angle 12. So, as you can tell that, we're going to name a pair of vertical angles, and angle 1, as you can see in our diagram, and angle 5, and angle 3, and angle 4, and so on and so on. So based on what we know about the vertical angles, what must the measure of angle 2 be? Angle 9. So as we can see that 2 and 9 are vertical and they are congruent. Therefore, the angles 2 and 9 will be 63 degrees, but respectively 61 degrees. So what is angle 7? Let's see. The measure of angle 7 will be 56 degrees. And the reason why I know that because the sum of the measures of interior angles of a triangle are 180 degrees. So I added 61 and 63, which was 124, and then I subtracted that sum from 180 and got 56. So that's how angle 7 became 56. So now we're going to name a pair of alternate interior angles. Let's see what they are. So angle 5 and angle 7 are alternate interior angles, as we can see here. So therefore, the measure of angle 5 is also 56 degrees. And so next we're going to do angle 3 and angle 9. They're alternate exterior angles and therefore congruent. Since line 1 is parallel to line 2, angle 9 is vertical to 61 degree angle. So the measure of angle 9 and 3 are both 61 degrees. And as you can see here, that we have our chart to let us know about the different congruents. So we got 1 and 5, 3 and 4, 6 and 10, 8 and 11, 7, 12, 5 and 7, 3 and 9, 1 and 12. And then as you can see over here, we have our supplementary pairs, which is 6 and 9, 9 and 10, 11, 12, 8 and 12, 7, 8, 4 and 10, 4 and 6. And they're the same side interior or consecutive. And then we have 5 and 8, and that's the same as what we were saying. Question number 2, we're going to demonstrate how to find the measures of angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. As you see here, that P, A, R, and Q is that's parallelogram, right? So what do we know about a parallelogram? Well, the opposites of parallelograms are congruent and consecutive angles are supplementary. All right. So what you can see here that the sum of the measures of the angles of a triangle is 180 degrees. All right. So how will we solve this? Okay, as we know that angle 1 right here, it's only angle that you can find with the information given. So it's given to us. So it measures 180. So how we would do this is we would do 180 minus 74 plus 26, and it's going to give us 80 degrees. All right, so that's how we will find that. And so our other ones will be like 5 and 1, and they're congruent, so they'll both be 80 degrees. 2 and 7, congruent and supplementary to 1, so they both will be 100 degrees. All right. 7 and 8 are supplementary to so 8 is 80 degrees. And as we can see here, we have our chart again that's showing us our congruent pairs, which is 2 and 7, 1 and 5, 7 and 8. And also we have our supplementary pairs, 2 and 3, 1 and 2, 5 and 7, 7 and 8. So this will let us know what our angles and things are. Question number 3. Let's demonstrate how to find measures of angles in a concave polygon. Well, as you see here, we have our concave polygon. Look at there. So, how do we know that it's concave? Well, we can draw a line segment between two of the vertices, and the entire line segment is not contained within the polygon. All right? So how do we determine the measures of the sum of the interior angles of the polygon? Well, as you can see, we have n minus 2 times 180, and that's our formula that we will use, all right? Next, we will count our sides, which is 1, 2, 3, 4, 5, 6, 7, 8. So that's how we got 8 here. So we will do 8 minus 2 times 180 equals 1080. So then what we will do 2 times 12y plus 3 times 7y plus 3 times 3y equals 1080. Once we get all that and we add all those numbers together, we'll get 54y. All right, so we would divide 54y to 1080, and so y will be 20. So next we would do 12 times 20 equals 240, 7 times 20 equals 140, and 3 times 20 equals 60 degrees. So this is how we will find our measures for our concave polygon. All right, friends. So we're going to determine how to find measures of the interior, exterior, and central angles. And as we can see, they all add up to 180, all right? So of course, for our interior angle, we will use the formula again, n minus 2 times 180 divided by n. So again, we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would do 9 minus 2 times 180 divided by 9, and then we will get 140. So that's how we will do that. For our exterior angle, we would do 360 divided by n, 360 divided by 9 again, because that's how many sides we have, and we will get 40. Our central angle, we'll do the same formula as we did for the exterior, which is 360 divided by n, and again, you'll count the sides, and there's 9 sides, so you do 360 divided by n and equals 40. So as we see here, our interior angle, which is here, will be 140. Our central angle will be 40. And our exterior will be 40 as well. And here's a chart to show you guys the different types of formulas and things that you can use to determine our polygon. We're going to construct a cube vertices A, B, C, D, E, F, G, and H. Of course, here's our cube, and we have every alphabet here, and it's showing us, okay? So as you can see, our line is going to each side, right? So that is going to be our DEGH that we're looking for in this problem. And then next it asks us to construct a tehedron. So as you can see over in here where it meets, you see how it meets in the middle? So this is how it will be inside of that box. Question number 6. A tehedron. What is a tehedron? Well, of course, a tehedron is a solid having 4 plane triangle faces. So let's draw our tehedron. And this is what we get. See that? Isn't that just awesome? Yes, it is. And we're adding our vertices. Here's the body. All right, as you can see, we have our tehedron. And we have our 4 vertices that we see here that's in red. So that's 1, 2, 3, and 4. And now we're going to count how many faces we have. 1, 2, 3, and 4. Of course, you can tell that the 4 is located at the bottom of our tehedron. Our octahedron. Our octahedron is just like a triangle shape as we start. And it is a 3-dimensional shape having 8 plane faces, especially a regular solid figure with 8 equal triangle faces. So let's finish creating our octahedron. Here we go. 2, 3, 4, 5, 6, 7, 8, 9. There we go. So then we will add 1, 2, 3, 4, 5, 6, and that will be our vertices. Now we're going to add our faces to this. 1, to make sure it's correct. 2, 3, 4, 5, 6, 7, and I wonder where number 8 is. Can you guys guess it? There it is. Of course, our face 8 is located at the bottom of our octahedron. Lastly, our icosahedron. And we're going to do the same thing, and we're going to build our icosahedron. And what is a icosahedron? It's a solid figure with 20 plane faces. Wow, that is a lot. So it's shaped like a triangle as well. So let's see how many faces it has. 1, let's see, let's build it. And it's so neat how this is made. And it's much work that you put in. It's so creative. And it has so many faces to this icosahedron. And I'm hoping I'm saying it right. All right, so we got that together. So we're going to find out how. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 vertices. And as we know, with our red dots to help us, that's how to tell us how many vertices that we have. And of course, let's count our faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and of course, number 20 is located at the bottom of our icosahedron. Thank you, and I hope you enjoyed this lesson. Bye.